This is number 1 in chapter 13, which says calculate the minimum and maximum combined stress in the beam shown below. We can see the beam has 40,000 pounds of compressive axial force on it, and it also has a 2,200 pounds per foot uniform load that's causing bending stress on it. Now the 40,000 pound axial load is coming from a pre-stressing force, but that is located, as you can see by the cross section, at the centroid of the section. So that's just causing straight direct axial stress. So we've already said that P is 40,000 pounds, and that's a compressive force. You can see by the cross section the area is going to be 240 square inches. So therefore our axial stress, P over A, is 166.7 psi. It's a compressive stress, so that's going to be a negative. The bending stress is caused by the 2,200 pounds per foot. Now we can create a shear and moment diagram to come up with the maximum moment, which is going to be 110,000 foot-pounds. Now again, everything else is in the units of inches, so we're going to have to take the 110,000 foot-pounds and get that into inch-pounds. That's why you see multiplied by 12. The C distance is from the neutral axis to the outside edge of this rectangular section, so that's 10 inches. And then the moment of inertia is 1/12 bh cubed, with B being 12 inches and H being 20 inches. So the bending stress comes out to be 1,650 psi. Now again, you got to think the way that this beam is bending. It is placing a tension in the bottom of the beam and a compression bending stress up on the top of the beam. So if we create our table, as we've seen throughout this chapter, we know P over A is the same throughout the whole cross section, negative 166.7 psi. The bending stress is a compressive stress on the top of the beam and a tension stress on the bottom of the beam. So we can add those up, and you can see that the total combined stress on the top of the beam is a compressive stress, 1,816.7 psi, and on the bottom of the beam it is actually a tensile stress, 1,483.3 psi.